Review problem number 12. We're studying rocket motion in this example, and we've done a little bit of study of rocket motion so far. And one thing we haven't really talked about is some of the considerations you need to take into account when there are people riding in the rocket. One of the most important things is that you have to keep the acceleration that the person's experiencing below a certain amount. Otherwise, the person's gonna pass out or maybe get a brain injury. So humans can withstand sustained accelerations of about 5g for several seconds. Instantaneous accelerations can be larger if it's like a tenth of a second or something, but sustained accelerations a few g, like maybe 5g. This means 5 times 9.8 meters per second squared, or 49 meters per second squared. So given that we don't want to make our astronauts pass out or give them brain damage, what is the maximum burn rate, this delta m over delta t, that you could have for a rocket, for safe rocket travel? In this problem, we're given the initial mass of the rocket, and we're given the exhaust velocity, how fast the expelled gases come out of the rocket. So we have our equation for thrust of a rocket, the force of a rocket, was derived in the chapter. And let's rearrange this equation to solve for delta m, delta t, the burn rate. All we've got to do is divide both sides by the exhaust speed. And then I'll substitute the A value with 5 G's, 5 times 9.8, and we're done. That's the end of the problem. So, not a whole lot of math to do, but the concepts are interesting to think about here. And some of the other concepts I might want you to explain on the exam with rocket motion, well, I think the most important one is tell me how rockets move in the first place. What's the whole principle of rocket motion? And the idea is pretty deep. It really goes back to Newton's third law of motion. If you want to be able to move in any situation, you got to have something to push against. If I want to walk across the floor, I need to push backwards on the floor so the floor can push forward on me. That push is accomplished by the friction between my feet and the floor. Now, if you're in outer space, there's no floor to push against. So what you do is you push against the expelled gases of the rocket. It's also the same idea as the homework example we did with the astronaut who's like floating in space and needs to get back to the spaceship. So she throws her air tank, her oxygen tank, because that's the only thing there is to push against. So the principle of rocket motion is finding something to push against in outer space, and that stuff is the expelled gases. The bigger the exhaust velocity of those gases, the bigger the push, the greater the burn rate of those gases, the more of them there are per time, and the bigger the push you get. But keep in mind, you can't make this push too big if you have people on board, because